Okay, hello everyone. Welcome back. Good evening. Greetings from University of Merdeka, Malang. I hope all of you are doing well. My name is Andini Resvandini. I am your moderator for today's international collaborative teaching with the topic of blockchain technology and digital assets and microservices. This event is proudly presented to you by the collaboration of Office of International Affairs, Faculty of Engineering from University of Merdeka, Malang, and Central Philippine University. Please allow me to extend our warmest greetings to the Dean of Faculty of Technology Information from University of Merdeka, Malang, Dr. Mardiana Andarwati, SEMSI, to the Dean of Faculty of Engineering from Central Philippine University, Dean Danny Molina, to the Head of Office of International Affairs from Central Philippine University, Ms. K. Aden Gayo, MED, to the esteemed speakers of today's international collaborative teaching, Mr. Himawan Pramaditya, S.Kom, M.Kom from University of Merdeka, Malang, Mr. Richard Michael Coo, SE from Central Philippine University, to our students from the Faculty of Information Technology from University of Merdeka, Malang, and to the students from the Faculty of Engineering from Central Philippine University. It is my pleasure to welcome all of you to this international collaborative teaching. Please be advised that all of our lecture series can be found in our YouTube channel at OIA Unmer. For all the participants, we will have the Q&A session at the end of each presentation. Please kindly type in your questions in the Zoom chat box. Kindly state your name, where you come from, and followed by your questions. Now, as we have come to the main event of this lecture, please welcome Mr. Himawan Pramaditya, S.Kom, M.Kom from University of Merdeka, Malang. Without further ado, Mr. Himawan, the platform is yours.
Okay, thank you, Ms. Andini. Hello, everybody. Good afternoon, guys. How are you today?
Fine.
Fine. Hi. Fine, sir.
Well.
Some of you look sleepy. Okay, so let me try. Okay, let me try to share my screen. Wait. Okay, can you see my slides?
Yes.
Yes.
Okay, wait, I cannot see my own slide. Wait. Okay. So, what I'm going to do today is what was that? Okay, I'm gonna talk about blockchain technology and digital assets. Maybe a lot of you already know about blockchain technology, or maybe don't. So, as we can see ourselves nowadays, cryptocurrency, like Bitcoins and NFT are very popular. All of them are utilizing some kind of technology called blockchains. But what it is blockchain actually? There are a lot of things to discuss about blockchains, but I only have like around 30 minutes, right, Ms. Andini? 30 minutes to explain. So I will try to explain it as simple as possible. Okay, so we can start with what is this blockchains? What is this thing that we call blockchains? Okay. What is blockchains? Just like the name blockchains, you can imagine it like chains of blocks, as you can see on the picture. A chain of blocks that contains information. So once a data is entered to the blockchain, it will be very hard to change it. Okay, we will get more into this point later. Shall I continue? Originally founded in 1991, the blockchain technology is intended to timestamp digital documents, so it cannot be backdated or be tampered. But it's practically unused until around 2009, when the technology adapted by Satoshi Nakamoto to create the digital cryptocurrency called Bitcoin. Until now, we don't really know who is the real person behind the name of Satoshi Nakamoto. Not even sure if it's the old Japanese American man that are already widely spread on the Google. Okay, so if we want to look closer, what is this blockchain? Okay, we can see what's inside the block. Okay, inside these blocks, they have at least three information. The first is data. The data in the block is, in the case of cryptocurrency, it will be such as who is the sender, who is the receiver, what kind of coin, and what amount of coin being sent. That is the data. The second content is a hash. Hash is a unique combination of strings that are made by calculating the entire data, the first content, the data of the block, using some kind of encryption algorithm. Okay, it looks like these strings, just like a random strings, but it's unique. Hash is very useful when you want to detect change of the content of the block, because when a content or the data of the block is changed, it would result on a different hash number. Okay, and the third content of the block is the hash of the previous block. So at least they have three information on each block. One is a data, the second is the hash, and the third content is the hash of the previous block. So we can see in this illustration below, we have three blocks: the first block, a second block, and the third block. So the first block has the hash number like 1C8F. The second block has the hash number of 6BQ1. It also saves the hash of the block before it. It has the hash of the block number 1C8F, and so on. So what will happen if someone try to change the content of the data inside this block? If someone changes the content of this block, the hash will change, just like I explained before, because the hash is a calculation of the content of the block, right? So when the content is changed, so do the hash will change. Like maybe it's become something like 6BQ7 maybe. And what will happen is it will not be the same again with the hash saved on the blocks after that. So it will not match the hash that is saved on the block after it. Okay, so every block after this block will be considered invalid. So that's why we can consider the technology of blockchain is very safe, because once a data already entered the blockchain, it will be very difficult to change the content. Okay. Okay, another feature that, sorry, how to erase. Okay. Another feature that make the blockchain technology is so safe, it's the type of network that they are using is called a peer-to-peer type network. Yes, because it is decentralized. So it was different to a normal server where you store your data in one place. A blockchain technology is using peer-to-peer type of network. We can see on the picture right here. It's the representation of peer-to-peer network where the computer image is representing a node. So there is like this one is a node, this one, this one, this one, and a lot more in the actual nodes through the world. So for the information, right now or yesterday, there are almost like 41,000 active nodes throughout the world. Okay, so what will happen when a new block is created? So when a new block is created, every nodes will have a copy of a new block. A new copy. I mean like this, yeah. Yes. Okay. Every nodes will have the new block, and then they will create like some kind of consensus that decides which blocks are valid and which blocks are not. Okay. If everything is checked out, everything is okay, then they will add this new block to their own blockchain. Let's say if we want to join, we want to join the network as a node and want to change or tamper the blocks. Maybe we will, let's say this node is us, and we want to change the content of the blocks. Then all other nodes will say that our blocks is invalid because our blocks content is not the same with their records. Okay, so as a distributed ledger, once a data has been recorded inside the blockchain, it will be very difficult to change it. So it has two traits that make Bitcoin is secure. One is because it cannot be changed, and two, because it was recorded on so many nodes throughout the world. So you cannot just simply change the record, because you need to change at least more than 50% of the nodes throughout the world, and that's about roughly 21,000 nodes. So good luck with that. Okay. Okay, let me continue. Let's talk about smart contracts. So as the time went, blockchain technology is constantly evolving. The NFT that we now often hear are also the development of blockchain technology. The important technology that become the foundation of the creation of NFT is the development of smart contracts. What is a smart contract? Smart contracts is a small program embedded in the blockchain to create automated trade contracts. A smart contract acts just like a normal contract, but in a digitalized form. Okay. To make us understand better about smart contract, we can analogize the smart contract to the project Kickstarter. Have you ever heard about Kickstarter? Kickstarter is a website, a third party who connects between a product team and supporters. Someone can join the Kickstarter as the product teams, and they can create a project. Yes, they can promote their idea. They can set a funding goal, and collects money from supporters. And you can also join the Kickstarter as a supporter. You can browse what kind of projects there's, and maybe you can fund the project that you are interested in. If the funding goal is met, Kickstarter will deliver the money to the product team for them to start the project. If the goal aren't getting enough support and doesn't meet the funding goal, the money will get refunded and transferred back to the supporter. In this case, both party, the supporter and the production team, need to trust the Kickstarter to handle their money before anything happens. Okay, so what if we can make a digital contract that acts like the Kickstarter? They can collect money from supporter and deliver it when the conditions are met. So with smart contract, we can create a similar system that doesn't require the third party like Kickstarter. And since it's written on a blockchain, it inherits the same property that is immutable and distributed. Immutable means once a smart contract is created, it will be stored on the blockchain and nobody can change or tamper the contract. Just like the cryptocurrency. And distributed also means that it shares the same network in the blockchain. It was peer-to-peer type. So the output of the contract will be validated between a lot of nodes. Just think about these people as a nodes. So no one will be able to forcibly release the funds because, let's say, these nodes want to release the funds on the contract forcibly. Another node will deny, because if they say the conditions are met, another node will say no, the conditions are not met. So the release of the fund will be denied. Okay, that's why it's about the distributed kind of network will make the smart contract very safe. So what kind of network support smart contract? Maybe we already hear about this network. There are a lot of network, but the biggest network that are known to handle smart contract are Ethereum. There is also Binance, Solana, Matic, and so on. That's why we can find a lot of Web3 games, play-to-earn games are usually built around these networks because of their massive support of smart contracts. Smart contracts are written in Solidity language that has a similar syntax to JavaScript. Although Bitcoin networks also support smart contract, but it's in a very limited way. And there is rarely a case that utilize a Bitcoin network for a smart contract. Okay, so we have already discussed that smart contracts are the technology that made NFT possible. So let us talk about the connection between smart contract and NFT. So NFT are essentially a smart contract that lives on certain blockchain network. The contracts save unique properties of the item and track of the ownership. As we can see on the illustration, we can see some kind of NFT properties the address and the owner address. And smart contracts can also be programmed to give the creator some royalties every time an NFT changes ownership. Like this NFT is from a game called Ace Per Chain. It made by Indonesian developer. We can see here that they have like 5% royalty to the creator every time the NFT is being traded. Okay. Talking about NFT, what is NFT? NFT stands for non-fungible token. Non-fungible means it cannot be exchanged one another because it is unique. The example of non-fungible is an art. Yes. An art is unique because you cannot simply exchange art. You cannot exchange Mona Lisa by Da Vinci with paintings from Van Gogh. Another example is your pet. Your pet is also non-fungible because you cannot exchange your pet even it's with the same animal, with the same breed, same age, and the same color, because they have unique connection with the owner. On the other hand, fungible can be exchanged one another. The example is like money, Bitcoin, or a bottle of water. You can always exchange one Bitcoin with another Bitcoin, for example. So, okay, that's explain what it is mean with non-fungible. Okay, back to the NFT. So, what is an NFT? NFT is an innovation in the blockchain technology that allows you to own a particular digital item. You know that owning a digital item could be tricky because digital items such as music, image, or anything stored in digital form can easily be copied and shared and stored everywhere. So, how to prove an ownership of a digital art or a digital music, since it can copy it and distribute to anyone quite easily? Again, the blockchain can solve this problem by using NFT. Okay, but there is these things about NFT. The NFT is only represents ownership. The content of the digital items, it's not stored inside the blockchains, but it could be stored on another place. Maybe everyone can also download the same item. So the NFT is only represents the ownership. It's just there, maybe just for breaking rights. Okay, but there is this things. If you own an NFT, you are the buyer. You own the original ownership, but the creator still keeps the copyrights and reproduction rights. So although you have the original, the creator still can, in the case of digital arts, even though you have the originals, the creator can still print and sell it anywhere. Okay. NFT can be used to sell items that are considered unique, limited, and needs a proof of ownership. For example, digital arts, in-game items, maybe, or music. So let's see an example of some of the most expensive NFT that already sold. The most expensive NFT sold is this one. It's called Everyday, the first 5,000 days by People. People is the artist. It sold for around $69 million. or equals 1 trillion rupiah or 4 billion Philippine peso. There's a lot of number. Another one is this one. This is called CryptoPunk number 7523 by Matt Hall and John Watkinson. It sold for almost $12 million just for a digital art like this. But what make it so expensive? We have to remember that prices is driven by demands. Okay, so things are worth determined by how much people willing to pay for it. If I made an NFT and I decided to sell my NFT for $1 million, and somebody willing to pay it for $1 million, then my NFT is worth $1 million. Let me get back to the previous slide. We can see in this painting, it's not an NFT, but it's just a normal painting. It's called painting number 6, Violet, Green, and Red by Michael Coo. It is sold for 150 million euro just for a painting like that. Why? Because someone willing to pay that much for it. So the value is hundreds of millions of euro. So that's what's make a price of an NFT is because someone's willing to pay for it. If nobody wants it, then it become worthless. So some company want to increase the value of an NFT by adding an extra feature. Maybe making a game for it, maybe creating exclusive concert for the NFT owners, and so on and so on. We can see in this picture is the sandbox. The sandbox are selling like a digital lens on the metaverse. The metaverse, the sandbox metaverse, their own metaverse. For, I don't know, like last time I checked, it was around the cheapest land that they sell is around like $800 for the cheapest land. The cheapest land is like in the map, just like one dot here. It's priced like $800. The bigger land could be a lot more expensive, and you can place pictures on it for maybe a marketing purpose. But to increase the value, you can they make a game for it. So you can enter your land that you have already bought and buy more NFT in the shape of like tables and furnitures, buildings. So you can collect NFT. You can own land in the form of NFT, and you can collect NFT again in the form of furnitures and buildings, or even weapons, armor, and so on and so on. Okay, I think that's all, roughly in 30 minutes. I give it back to Miss Andini. Thank you.
All right. Thank you so much, Mr. Himawan, for a very interesting sharing about blockchain technology. Actually, in the chat, we have some questions already, and some it's already answered by the students. So, but maybe you can help to answer the question as well, to elaborate the answer. Okay, let me start with the beginning. From Nero Heavy Divinci Damora, can I ask, what if, oh, not this one, sorry. Yeah, Johannes Baptista Naput. Excuse me, sir, what makes this NFT different from others? Is it only use case and the branding? Because Zulfikar already answered, it's the use case and the branding. What makes it different, Ms. Himawan?
I'm sorry, can you repeat? I'm still reading the
chat.
question
Okay.
on the chat.
It's the question by Johannes Baptista. What makes NFT different from the others? And Zulfikar Sasongko already answered actually. What makes the NFT different is the use case and the branding. Is it only those two things that makes it different?
I actually don't really understand what Johannes mean by different. If Johannes is here, can you maybe turn on your microphone?
Yeah.
Yes, sir. Yes,
Yeah.
sir.
Yes, go ahead, please. Yeah.
I'm here, sir.
Yes, go ahead. You can ask the question directly. What do you mean by different? Is it what makes one NFT different with the other? Maybe it's like that.
Maybe like one NFT with another NFT, or
Johannes, is that correct?
Yes, miss. Yes, miss.
Oh, okay. So yeah, actually what makes it different from one to the other?
okay. So actually there is no actual difference from one NFT to the other NFT if the creator wanted to make it so. So like the uniqueness, the scarcity is actually just artificial. Like let's say the CryptoPunk that I already said you an example before. If the creator is trying to make another similar ones, make a double of triple of it, it can be done. But each of that NFT will have a different address, and they will have a different owner also. So if an NFT is considered rare or unique, it's because the creator wanted to be like that.
Okay. So actually you can duplicate your own NFT. For example, I have one NFT and then I want to duplicate and sell it to other people. Is it possible?
Yes. Or a lot of the case in the NFT market is like another people make a similar image and then sell it.
Okay, so like the counterfeit one, the fake one.
Yeah, just like a fake one, but you know that it's not the actual image that we are buying, but you know, just I bought the real one, the expensive one, just for breaking rights.
Okay, so it's just a replica of the real one. So
yeah,
you get the real one for that price, because you know
just,
it's so cheap. It can be the real one.
Let's say it's like, let's say it's a Mona Lisa painting. You can find a high resolution of Mona Lisa painting and print it as big as you can on your room, but you know that it's not the original and it doesn't worth anything. So that's it.
Okay, that's good. Thank you so much for your answer. And actually you are also answering another question by Heavy Divinci Damora. Okay, I like a bit difficult to pronounce your name because I'm just so used to call it Da Vinci, not Da Vinci. You know, the famous painter Da Vinci. Okay,
yes.
So you want to ask, what if I took a screenshot and then is it make it illegal to sell it again? The counterfeit.
You can try to screenshot of the end. You can even somehow you can download the real NFT picture and own the same picture that the buyer have. But what you didn't have is just the proof of ownership. You didn't own the picture.
All right.
Everyone in the world can have the picture, but you didn't own it.
Okay.
Like that.
The ownership, it's expensive. The one that is expensive is actually the ownership, right?
Yes.
It's already answered by Risky. Actually, he said that NFT is unique data like primary key in DB or NIK in our ID card. You can clone it. You cannot clone it, but you can transfer it to another people. The purpose is to show ownership of an item. If you learn about copyright, NFT is very useful for that. We can avoid piracy. So the most expensive thing is actually you are buying ownership about the NFT, about the item. So next question is from Joshua Lian Aldora. Sir, what do you think about the cryptocurrency, which is currently going down a lot? Is there a possibility that the price will rise again?
Okay, Joshua, are you a trader? Okay, for now, like in mid 2022, we are entering the phase of a crypto winters. So the price of crypto going down a lot. Maybe the prediction is like it will be like this for maybe a couple years from now. So is there a possibility that the price will rise again? Of course, there is always a possibility if we check the price of the cryptocurrency, it rises around like 2014 and then 2017 and then last year 2020 and until 2021. So yes, there will be a possibility, but I'm not really sure when.
So actually, it's the basic lesson of investing. Okay, do not invest all your money in the same business. For example, like this NFT, you can invest some, but do not invest all, because you never know. Sometimes the price will drop, or sometimes the price will increase. Okay, now another question from Irfan. Hello, I would like to ask a question about blockchain. Is there any limit on the blockchain? I mean, the block itself, does that have the limit per day?
Actually, if you say about is there any limit to the amount of the blocks, there is no limit as long as the data said so. But does it have a limit per day? Yes, some kind of blockchain network, they create a limiter to limit how many blocks are created per day. Like Bitcoin, they have a mechanism of like proof of work that limits the creation of each block is like around every 10 minutes, like so. So 10 minutes, like 6 blocks an hour. So that makes like 70 something blocks per day.
Thank you so much. There is some questions from Dafa Karyudi. Is it possible to turn NFT into a currency if they make lots of duplicates? So it will be called a cryptocurrency or still NFT?
You cannot turn an NFT into a currency because the factor that I explained to you before, because NFT is not fungible. They are non-fungible. So it's not the same one, or you cannot pay with I want to pay for my college tuition with 3 CryptoPunks. You cannot do that, but you can pay with maybe 1 Bitcoin, like that, because every NFT might have a different price of them. So we cannot generalize the price of one NFT with another NFT, even they make a lot of duplicates.
Okay, so the name itself, non-fungible, make it impossible to become a currency.
Yes.
All right, thank you so much. There is another question from Joshua. I'll ask one more question about NFT. Is there a law that protects the copyright of an NFT? If an NFT is taken for granted, like in a screenshot or something else?
For now, there is no law that protects the copyright. Like I said before, the NFT is just proof that you are the owner.
No.
Even the image, everyone can download. Everyone in the world can download the same image and that you have, but only you, the owner of the NFT, have the ownership like that.
All right, understood. So another confirmation is, so that means from Defincy, in NFT, we buy the ownership from the photo itself, but people can still screenshot or download, but cannot own the ownership. Yeah, that's correct. I can confirm
Yes.
with you. Yeah. All right. Is there any more question or discussion for Mr. Himawan's lecture? Okay. Oh, there is one more question from Rismawan. What do you think about metaverse future, that we can see many brands like Adidas, Balenciaga, Gucci, and so on? They they make investment on metaverse, but they get lost more than $9,000. Is it or 9.2? What is this? Oh, million. Okay, $1 million. Is it still good for investment or not?
Like I would say that every investment, not just in metaverse, is only valuable when people have trust to the investment.
Okay, if you ask about whether it's worth it or not, when you invest on something, it's actually you are gambling, right? You
Yes.
will never know about it. Sometimes
You
the
will.
price will increase, sometimes the price will go down. So for the big brand, like $9.2 million for the big brand, maybe it's not much for them.
Yes. The process why the brands are investing, it's because the brand are trusting something. But if people didn't trust to what they already invest, then it become worthless.
Okay. All right. I have one more question from Jofimar. Good day, ma'am. I'm Jofimar Erlan, and I would like to ask a more recent news involving AI arts. In line with this new development in AI, is it possible for an AI to be directly sold as an art? And if so, to whom will the ownership be? Artificial intelligence as an art, and you want to sell that. Is it possible?
Okay. As long as the product is a digital product, you can sell it as an NFT. Even I've read about someone selling the first Twitter post, the first tweet of the Twitter owner, and it has been sold for almost $3 million. So as long as the product is a digital product, you can sell it as an NFT. I mean, like sell the ownership, not the actual product. So yes.
All right, thank you. And one more question again, how about blockchain security system? Is it safe because of the many hackers circulating now?
Okay, so I can say that the blockchain system itself is actually safe. The hackers usually stole money from the system around the blockchains. In example, last 3 months ago, there are a hack that targets what do you say, the currency in Axie Infinity? What it is? The currency of Axie, I forget. Yeah, it create a loss for like $100 million, but it doesn't attack the blockchain security system. It doesn't attack the blockchain system itself, but it attacked the bridge from the trading platform.
All right.
Yes.
Thank you so much, Mr. Himawan, for the very interesting sharing on NFT and blockchain technology. A lot of students that asked the questions to you, and there are still a lot of discussion in the chat, but I will stop for the question session for now. I will continue with the next lecture, and we can have some more discussion at the end of this class. All right. Let's see. We will listen to the lecture by Mr. Richard Michael Coo from Central Philippine University. Mr. Richard, the platform is yours.
Hello, everyone.
Hello.
So I do apologize for yesterday. Thank God that no emergencies today, and we were able to get on with the collaborative teaching. All right, so let me share my screen. All right, is it visible?
Yes.
Okay.
Yes.
All right, I also sent the link to the slides on the chat box. So I'll be talking about microservices, and honestly, I'm not sure if 30 minutes is gonna be enough. So let me just try. So yeah, some boring introduction about me. So I'm just actually part-time instructor at CPU and a full-time senior Node.js developer. And so what to expect for the next 30 minutes? I'm not going to bore you with things that you will forget tomorrow. But if you want to learn more about microservices, there are lots of resources online. The link is there. And yeah, so this one is microservices.io, and you could learn a lot, especially patterns and things like that. Okay, so anyway, so before we write some code, we're not going to write some code yet, but so the outline for today is what are microservices and why should undergrads learn microservices and patterns. There are lots of patterns if you just take a look at this link right here. It's unclickable. All right. There are tons of patterns, and yeah. But I'm going to choose one from the composition and for one from data management, and yeah, one from or two from data management. So that's decomposed by business capability, database per service, and API composition. And then we'll have our hands-on workshop. And finally, some anti-patterns. Anti-patterns are bad practices. There are a few of them, I think 7 or 8, and I just choose one because of time constraints, and parting advice and Q&A. All right, so typically when we write our web or our full stack applications, right, we have a front end and we have perhaps a back end containing your business logic, database access, and if it's just one back end, that's what we call a monolithic architecture or monolithic applications. So microservices is actually splitting up this into several chunks or several pieces like that. Okay. So formally, it will somehow look like this. So you have an account service that gets its own database, maybe an inventory service. Maybe this is for something like Amazon, or we're in Southeast Asia, so maybe Lazada or Shopee. So inventory, shipping, account. So each microservice gets its own database, and your mobile apps or your web apps or your front end will only be able to access the what we call the API gateway. So we don't even need this in many cases. If you're writing a single page application, they could all talk to the API gateway. So formally, microservices are, the longer name for that is microservice architectures and architectural style. The structures and application is a collection of services. So we chop it up into multiple pieces such that each is maintainable and testable, loosely coupled. You could actually deploy a microservice independently. So with monolithic, for example, if you're going to make one tiny change, you have to redeploy the entire backend. And if you don't have any like replication of some sort, that's gonna mean some downtime. So, and if your app is very, very large, your builds are gonna take very, very long. So for example, right now at our workplace, it takes around like 10 to 20 minutes to build Docker images. So if your app is very huge, it's gonna take a while to build if it's monolithic. So, and it's usually organized around business capabilities like this one. So maybe Lazada has account, inventory, shipping, payments. So each business capability has, it can be written as a microservice. And for large software companies, each microservice is actually owned by a small team. So maybe for a startup, a team could own 2 to 3 microservices. So right now at our workplace, there are only 4 of us, but we have 7 microservices. So we do own everything. But for larger organizations or larger companies, one team owns 1 microservice. And so the benefits is that it enables a rapid, frequent, and reliable delivery of large, complex applications. And if you take a look at the picture on the right, you could actually write microservices in different languages. So with a monolithic architecture, so if, for example, you write this in Python, right? And we know that if your software is successful, it's gonna live for years, right? So for example, you take a look at Facebook. Facebook has been around since 2004. Twitter, maybe our favorite shopping sites like Shopee or Lazada, they've been around for more than a decade or even more than 2 decades. And if you started out writing that in Python, and maybe 10 years later, Python is not that cool anymore. We're encountering tons of issues. Why not Node.js? It has tons of features that suit our growth, our scale, right? It's going to be very, very hard for you to do that. It's going to be a very expensive rewrite. So imagine rewriting a giant monolithic app from Python into Node.js. That's going to be very, very expensive. But with microservices, a company in the Philippines, actually, it's called Paymaya. They're using microservices, and they're actually able to, start off with, I don't remember actually what they used, but I think it was PHP in some parts. But when Node.js came, they were able to write a small chunk of their business capability as a microservice. So, yeah, so it's easier to evolve your technology stack if you're using microservices. So maybe right now, Go and Rust are getting more and more popular. So maybe, Go is really going to help us because it's very, very fast compared to JavaScript or TypeScript. So you could write another microservices in a different language. And hopefully we could cover that this evening. Let me check the time. All right. So this is a typical triangle in software engineering. So it's usually people, process, and technology. So process, people, so agile and cross-functional teams. If you have that, and if you use microservice architecture, you're gonna have an easier time making successful software development. So let's just skip that one. And microservices are starting to become more popular. So we have here like a chart, and actually only 20% of 1,500 respondents answered that they don't use microservices. So that means around 80 of the survey participants use microservices. And should undergrad students like you learn microservices? Well, there are jobs that use microservices, and even fresh graduates are welcome to apply. So like this one, microservices, like that one. So I'm sure, apologies if these are Philippine job results when I tried to make a quick search. But anyway, I think Accenture is pretty global. I think you've all heard of Accenture, and they do have positions like that. Okay. And let's move on to patterns. So if you're familiar with design pattern, it's actually a common solution to a recurring problem. So if we take out the words software design and maybe design here, so a pattern is actually a general and repeatable solution to a commonly occurring problem. So they are best practice solutions. Okay. So there are patterns for architecture, like microservice is actually a pattern, and microservice itself has patterns of its own, and we're going to take a look at a few of them. So how do you decompose your monolithic app into small chunks? So one of the most obvious one is by business capabilities. So for the likes of e-commerce applications, so product catalog gets its own microservice, inventory will get its own microservice, order, own microservice, delivery, shipping, its own microservice, payments, its own microservice. So that's one of the most obvious ways to decompose that one. And the more preferable pattern actually is to have each microservice get its own database. So maybe your catalog, because you want to have more freedom on what to include in your product catalogs. So maybe you want to use a NoSQL database. So like MongoDB, shopping cart here, maybe you don't need to really persist that one. So maybe use Redis. So Redis is an in-memory database for those who are not familiar. And maybe ordering, you want tons of historical stuff. So maybe you want to use an SQL database or a relational database. So something like that. And another accepted pattern is actually one database for everything. Some actually, I actually just stole this picture from the internet. And some actually consider this as an anti-pattern because it has many drawbacks. So one of which is development time coupling. So maybe if you have only a single database, you need to have more coordination between teams, right? Because one team is going to make schema changes to this, another team is going to make schema changes to this, and you are kind of tightly coupled, right? So there is coupling, and if the other team takes a while to respond to your questions, or maybe you're in different time zones, then it's gonna slow down development and even runtime. So because each microservice share a single database, maybe something here will interfere with that one. Maybe so something like that. Maybe the ordering microservice is gonna lock the products table. So when it's locked, the other microservices like catalog and shopping cart will not be able to access them. So that's runtime coupling. So they interfere with one another, and a single database may not be one size fit all, because, like, for example, a product catalog, if you take a look at Lazada or Shopee, they are, with laptops, you have different fields and attributes, right? Like CPU, RAM, and if you have chargers, it's probably going to be wattage, like 65-watt charger and things like that. So you might want to consider a NoSQL database for the product catalog. So, and maybe a very compelling reason is that different libraries deal with databases differently. So if you have worked with multiple ORMs or multiple database libraries, a few examples would be they create migration tables differently. So for example, Next.js, it creates a table called Next Migrations and a table for locking migrations. So what happens if this one is written in Prisma, right? And the other one is using Next, and you only have one database. So you'll have, each will create its own migration table, and it's not gonna work properly, right? I'm sure you could all agree with that. So that is perhaps one of the most obvious reasons why we should not do this. And if you've worked with MongoDB or Hibernate, they have locks that, for example, Hibernate uses version, and MongoDB uses Mongoose uses __v. So different ways of doing locks. All right, and API composition, if you have multiple microservices, you just join them in memory. And of course, this one also has a disadvantage. If your RAM is not big enough, you're gonna run into memory issues. But for beginners and learners like you, this is one of the easiest and the most obvious ways to do it. You just take the results from microservice A and B and C and join them together in memory. All right, so ready? So let me check how much time we have left.
15 more minutes.
15 more minutes, okay. So hopefully you guys installed, I actually sent the list of things to install for CPU students, and also sent Sir Himawan with a list of things to install. We're gonna use NATS, so we're gonna use NATS. So there are many ways to install NATS, and you could run it using NATS server -v like that, or if you have a Docker image of NATS, you could run it like this. It's in the website. We'll name our Docker image Peanuts, and you could do something like that. And just, if you want to see what's going on, you could say Docker logs. F, I think, is follow Peanuts, so you could see the logs of NATS. Okay, so what is NATS? If you're going to have separate databases for each microservice, how will they be able to see one another? How do they talk to each other? So there needs to be some sort of messaging where microservice sends this microservice sends here, this microservice sends here, okay, and Nats actually serves this function of allowing microservices to exchange messages with one another. Okay. All right. So hopefully you have this installed, and the other one would be Nest.js. So Nest.js, if you have Node.js, make sure you have that, and Nest, the latest is version 9 right now. So hopefully you guys have that. And for Python and Panini, I think it's just pip install Panini, something like that. And to test if you've installed Panini correctly, maybe you could go to Python and import Panini. So if I import a package that does not exist, for example, import peanuts, is gonna produce an error. If Panini is not installed, it's gonna result in an error as well. But no error, so all good. And why are you going to use Nats? Because if you've seen from the picture, you could actually, each microservice could actually be a mini REST API, but REST uses HTTP, which is slow. That's one of the reasons. Another reason is that it's also not durable. So if the microservice is down and you send an HTTP request to it, it's just gonna fail. But with Nats, if you use Jetstream, it's possible. At work, we are actually using the older version of Jetstream, which is the Nats streaming server. So even if your microservice goes down, when it becomes alive again, it could still receive the message while it was dead, right? So that's one of the reasons. So Nats is just faster. You can see from the benchmark here. And it's also simple. Oops, sorry. I clicked the Twitter link. Okay. All right. So let's start. Let's create a microservice. So Nats new micro. And let's wait for this to install. So let's just keep this tab handy. While this one is installing, you could open another tab in your command line and maybe say nats publish. Just like an email, you have a subject here using a dot notation. So for example, CPU.Unmer and any message that you like. So any message. So your Nats server should be able to receive that one. Right. So you have here the subject and you have here the message. So it's handy to keep this tab open. All right. So our Nats microservice is up. Okay. So what we could do is open it in VS Code and VS Code. Oh, it's on the other screen. All right, here we go. Oh, sorry. CD micro and open this in VS Code. Right. And let's color this with Peacock so that we could tell the windows apart. We're gonna have 3 VS Code windows because we're gonna have 2 microservices and 1 API gateway. So just open source. And if you're familiar with model view controller, so it's okay. If you're not familiar, then it's also okay. just to make sure that this is running, you could just go to localhost 3000. Did it run? Oh, sorry. npm start. Okay, and if you see hello world, then it should be okay. But we're gonna convert this into a microservice. So we will we will install Nest.js microservices package. We're gonna install this one and import maybe message pattern from, there you go, import message pattern from Nest.js microservice and change this get into message pattern. And you could actually put here the pattern that you want. So maybe it's CPU Unmer. Okay. And what we're going to do is to actually log that it received the message, because we're not going to see the return value for now. So received, something like that. And we could use the payload decorator. Okay. We'll just say received payload. So what we'll do is restart this microservice and send a message to it. Where's our message earlier? There you go. Okay, our app, sorry about that. Our app is not yet a microservice. It's just an ordinary web backend. So what we're gonna do is we say import I actually don't remember. So let's just take a look at the documentation. And this is something that we don't do often. Once you've created this as a microservice, then it's already okay. Okay. All right, cool. Okay. So we're actually gonna import transport from Nest.js microservices. And instead of creating a normal application, we're gonna create a microservice. And microservices don't have a port, so let's just use app.listen. And what else is missing? Okay, so this one, aside from app module, it requires a second parameter. So there are many ways to basically exchange messages. So we have HTTP, we have NATs here, as we mentioned earlier. So we're going to choose NATs. So we're going to tell Nest.js that the transport of our choosing is transport.nats. Right. So that should okay. So npm, we have to install nats as well. Right. Bad. Okay. So sorry. Payload should only be in JSON. So all right. So the server crashed. So this one should be JSON. So let's have X1 here, like that. And perfect. So it received X1 and X44. Okay. So that means that our microservice is working. So what I'm going to do next is to make an API gateway. So I open another tab. You're gonna have lots of tabs here if you're going to do microservices. So I'll say nest new API gateway. So it takes a while to install. So time check.
Five more minutes.
Okay, 5 more minutes. Okay, so let's just try to get this over with quickly. Nest, right, perfect. And CD API gateway, open in VS Code. Let's give this a different color, right, green. And what we're gonna do is to install Nest.js microservices and Nats as well on this API gateway. And all right. So to talk to our microservice, we need the client module, and I don't remember that as well. So let's just what's the faster way to do this? Let me open my cheat sheet and okay. Let's just paste some code here. Okay. This one should be an array. So like that, and like that, and transport should be imported. Okay. The other red underlines is from ESLint complaining that the code is not formatted properly. So in our controller, we're just gonna have to inject our client here. Like that. Okay, so this inject, we need to import that from Nest, and this one will also import that one. So what we'll do here is to let's say return this, the client. We're going to send a request. So the subject that we use is CPU.unmer, and we're gonna, create a JSON payload, let's say x50, like that. Let's just get rid of this one. And from our microservice, okay, what we're gonna do is to actually return x, and given payload that x, we're just gonna add 300 to that. And it's no longer a string, so let's just get rid of that and let TypeScript infer. So yeah, so if we restart this one because we made changes, and maybe maybe start this one as well. All right. So when we go to the browser, and refresh this one. So it's actually X350. So that means that that means that whatever the X of the payload is, we just add 300 to it. So since this is 50, becomes 350. If I make this 44 and maybe restart this one, so this is gonna be X344. So that means that our API gateway is talking to our microservice properly. And I think I don't have time anymore, right?
Yes, 1 more minute.
I have one more. That's
Go
probably.
ahead. Actually, go ahead. I don't see any question yet, so you may continue if you still want to explain.
Okay. So the other interesting part here is we could actually talk to Python, and I'll just to make this quick, I'll just make another tab here and make their Python service. And I'll just, just to easily tell this, oops. Okay, let's change the color of this one so that you can easily tell it apart. Okay, so I'm just pasting, this is the exact code you'll see from the Panini website. And we can have another service. And you could actually print that it has been processed. And Nest.js actually, this is actually the payload, and Nest.js actually has data, another key data before you actually get your X. So we could actually do something like ×5, for example. So whatever X is given, we'll just multiply that by 5. And we could run this one. So we have here a microservice in Python running, and we could actually talk to this Python microservice from Nest.js. From our API gateway. So maybe maybe another get request. So maybe I could put Python there and get Python calculation, something like that. And we could actually send, because we use another service in Python, right? So another service. So we could put another service there and maybe put X15. So 15 times 5 will be 75. So what we're gonna do is restart our API gateway. And it should still talk to the Nest.js microservice, but it could also talk to the Python microservice, right? So Python multiplies our X by 5. So if we change this to, we're gonna do something cooler. For example, we're gonna say query Rx there, and that's actually a string. So we're going to do something like that, and we're going to convert it to a number because all query strings are strings. Like we're gonna do something like that and restart our API gateway. So now our X will come from the URL. X is equal to 28, 27, so 27 times 5. It's not working. Sorry. It's supposed to be RX, right? So it works. 50 times 5 to 50, 33 times 5, 165. Okay, so I think that ends my coding demo. Yeah, sorry, I exceeded the time limit. But that is just a short demonstration on how different programming languages or technologies can talk to one another, and how you could decompose a large app into small pieces, and you could even combine different tech stacks to for your app. And many large companies actually do that. So it is similar to the picture that you see right here on the right. So it's just JS and Python for now. So any questions?
All right, thank you so much for a very elaborate presentation and hands-on on microservices. Okay, I have one question from Ahmad. Hello, sir. I would like to ask something about microservice. How can we make a microservice with GraphQL? Is it GraphQL? For example, we have two services. What should we do? Should we merge two services or what? I don't really understand about how to make graph in microservice.
Oh, GraphQL. Well, GraphQL could be part of your API gateway, but for the transports, instead of GraphQL, maybe you could consider gRPC. It's by Google, and it also has types just like GraphQL. It's actually faster as well. So, for example, this one is actually supported by Nest.js. And another thing that you could possibly consider is stitching. GraphQL actually has schema stitching. That's something that you could use actually. So maybe one microservice produces GraphQL, another produces GraphQL, and you could stitch them together. But normally, because one of the disadvantages of splitting your monolith into several pieces is gonna be speed, it's gonna be performance, because instead of just everything being processed locally, now you have this extra network request. And so you want these inter-service communications to be fast. And GraphQL and REST, they're both HTTP-based technologies. So you might want to consider something that is faster, like NATS or gRPC. If you look at the benchmarks, they're going to be faster than HTTP, and by several factors, because HTTP is slow and JSON parsing is slow, but NATS and gRPC, they're using binary format to transport the messages. So it's not text, just like HTTP, but rather it's binary. Yeah, so did I answer your question? Or?
Yeah, I hope that answered your question, Ahmad. All right, is there any more questions or discussion from all the participants? If not, we are going to have the photo session. Please get ready to turn on your camera. Okay, Ahmad want to ask again, where is the best place for us to put the database in microservice? Should it be on the same server as the application, use a cloud database service such as AWS, RDS, or create our own database server?
It really depends because there are so many factors for this one. If you have multiple servers, of course, the pricing might be different and you have more things to manage, but some people like that because if your application is in one server, that means it will not share resources with your database. And if you, for students, of course, I think you don't want to pay for anything, right? So usually what happens is that your database servers are different from your application or API server. If you want, for example, if you use Render or Railway, you're gonna have, you have no choice but to have the database. So your service is on a different server and that's free. Your database is gonna be on a different server and that's also free for 90 days. This one is free for 90 days. Something like that.
Ahmad, is that answering your question, or do you want to ask directly to Mr. Richard? You can raise your hand and ask directly, actually. Ahmad?
Yeah, so did I answer your question?
Okay, no sound. All right, I think that should be fine. Thank you so much, Mr. Richard, for taking your time. And thank you so much, Mr. Himawan, for sharing about blockchain just now and the NFT. And let's have the photo session first. We have 10 slides, so please bear with me. Okay, thank you for the answer, Ahmad said. All right, you're most welcome. Take your picture. Please get ready and open your camera. Okay, 1, 2, 3. Okay, and then we will have second slide. All right, third slide, fourth slide, fifth one, sixth one, 7, 8, and the last slide, 9. All right, once again, thank you so much, Mr. Richard and Mr. Himawan, for
Thank you, everyone. Thank
sharing
you
your
for inviting me.
knowledge. Thank you for all of our students. You are staying in the class until the end of the class, 223 participants. Thank you very much and see you again soon. Take care. Bye. Thank you. Thank you, Mr. Richard. Bye.
Yeah,
Thank you.
Okay, if you
Sir,
have more
thank you.
question, please
Thank you, sir.
contact, all right, on the
Welcome.
slide, the contact details. Sorry, we will share the slide with
Thank you,
you.
Miss.
Don't worry, you are most welcome. Thank
thank
you.
you.
Bye.
Yes.
Thank you, Miss.
Thank you. Good morning.
Thank you so much, Ibu Cantik.
Most welcome.
Welcome. You are
Thank
welcome.
you. Welcome.
Halo, Pak.
Take care. Bye.
Halo.
See you again soon. Thank you. Bye bye.
Thank you, Miss.
You are most welcome.
Yes. Arigato samasta. Miss, ini nanti dapat sertifikatnya, Miss?
Dapat sertifikat nanti dikirim. Yang penting tadi sudah absen ya. Dapat sertifikat ya. Silahkan.
Absennya sekali aja ya tadi ya, Miss.
Sekali aja cukup.
Oh ya, oke, makasih.
Sama-sama.
Makasih, Bagas.
Silahkan. Terima kasih sama-sama. Saya end meeting ya. Thank you everyone. See you again soon. Bye bye. Take care.
Bye, Miss.